Hello everyone, this is Chris and long time no see. Is everyone doing well? I was quite busy the last few weeks dealing with the capstone, the FRM exam and the final exams. But now I'm back, so if you got any questions in arts, let me know, just email me. Alright? So today's topic gonna be multiple linear models. So multiple linear regression, and I hope this gonna help you with your stress testing project. Okay, so the multiple linear regression is quite similar with the single linear regression, but just adding more independent variables, and the method we use in this regression is still OLS. So that means its target is to make the model parameters are selected to minimize the sum of squared residuals. Okay, so you calculate the residuals and you square them and sum them together. So we have to make this number as small as possible. So this is how this linear regression, the R, to deal with your data. Okay, first we gonna have a data is according to my data. Okay, let's check it out. So my data is the stock returns of SPY, Exxon, Apple, and GE. Okay, what I'm gonna do is to run a regression on SPY, standing for the market, to against Exxon, standing for the energy industry, and Apple, standing for the technology industry, and GE, standing for the manufacturing. So the SPY is a dependent variable, and all these two are independent variables. Okay, so I bet you must have been so familiar with the command LM. LM is a command for linear model, so we're gonna run a linear regression, so use LM. So LM is SPY, then ExxonMobil, Apple, and GE. Data is absolutely my data. Okay, let's go. So here we got this regression and then the summary. Okay, there are a lot of information here. Look, so first it's residuals. So the OLS is to make the sum of squared residuals as small as possible. So look at the residuals, the minimum and the maximum, positive and negative. You can see here is quite small, right? So it's only 0.01, 0.012. So it's quite small. So I bet that OLS did a great job. And then we can look here. I want you to look here, the F statistic. Okay, someone asked me, what is F statistic? So basically, F statistic is to assess that how well the set of independent variables as a group explains the variation in the dependent variable. So that means F statistic is used to test whether at least one of the independent variables here, so one of the Exxon, Apple, or GE explains a significant portion of the variation of the dependent variable. So if we write it as the hypothesis testing, it's gonna be like the non-hypothesis gonna be the B1, B2, the B3, all the coefficients of them equal 0. And the alternative hypothesis is gonna be at least one coefficient, one beta doesn't equal to 0. So this is kind of like put all these independent variables together as a group to check if this regression itself explains a significant portion of the variation in the dependent variable. So if the F statistic is big enough, then it means the regression itself do explain something in a dependent variable. So this is gonna be your first step if you're choosing the right independent variables. Okay, the second part, we're gonna look at the R square here. The R square is, I know you guys know R square. So R square is what's the portion of the variation in the dependent variable is explained by the independent variables. So, and adjusted, as you know that the more independent variables you put in the regression, the higher R square is gonna be. And the adjusted R square is kind of like has adjusted the numbers of the variables. So no matter what, sorry. So after adjusted, then you can compare the R square between single regression and multiple regressions, and you can compare the R square between a regression with two independent variables and a regression with 100 independent variables. So this adjusted R square is adjusted using the numbers of the independent variables. So this is R square. And then here we can back to the coefficients. So the coefficients is the betas we want in the regression. And look here, so the estimated number of these coefficients, first is intercept, then cosine, then apple, and then GE. Okay, let's look at the cosine. So we can see the standard error. Standard error is the standard deviation of the sample. It's not for the population, it's for the sample. So we call it standard error. And then the t-value here is the t-value actually is the estimated number divided by the standard error. Then you got the t-value. It means how many standard errors we expect from these estimates. So over 7.271 standard errors is within. So this means that this is quite significant. So this coefficient is quite significant. And the last column is probability of bigger than the t statistic, probability of bigger than t value. So if you're expecting a number that is bigger than the t value, then that estimate that the chance, the probability you get this estimate is like really small. So it's more than like 1% or 0.1%. So it's really small. Then, so after we calculate this t value and the p value of the coefficients, we can see that under like 99%, because here look as 3 stars, so the coefficient codes says it's 3 stars stands for 0. So it means we can almost say that 100% that this ExxonMobil is not 0, is different from 0, and that is to say that it is almost 100% significant. So that's, we talk about the significance of the coefficients. Then we can see all of these 3, Exxon, Apple, GE, they got significant coefficients. But the intercept doesn't. Look at intercept here. So there's no star here, and no stars stand for 1, and it means it's not that significant. And we can check the standard error. Standard error, look here, is even bigger than the estimates itself. So this means the t-value is gonna be 0.274, and we're gonna have a 78.4% to expect the number to be greater than the t-value. That means it forced out. So actually we can see that over 78%, over 78.4% that we expected we're gonna get a intercept equals 0. So we have to say that the intercept is not significant, means that the intercept is 0, equals to 0. So based on these coefficients, we can write down the equation here. So the SPY equals to intercept plus the coefficient, the B1 times Croissant plus B2 times Apple and plus B3 times GE. This command, confidence integer, confint, is for the confidence interval for the all the betas, all the coefficients. So here, let's see Croissant. The range of the croissant is gonna be 4 in. That I would say there is a 95% of the croissant. The estimate of the croissant falls in this range, and as well as the Apple and GE, that these are the 95% range they're gonna fall in. And keeping in mind that when we talk about confidence interval, we always talk about it is whether a two-tail test or it is one-tail test. Okay, basically and generally, the rules are if you are testing, let's say the A is equal to 0, is equal to something, we use two-tail test. And if you are testing that if A is less than or it's greater than something, then always we use one-tail test. Okay, so if equals, we use two tails, and if it's less than or greater than, we use one-tail test. Okay, that is the principle, and you have to keep this in mind. And thanks to R, it already calculates the confidence interval, and you don't have to calculate by hand. And I hope you guys know how to calculate confidence interval, because I bet it will be on the test. Alright, and then we're gonna have the prediction. Okay, so the prediction, I think it's gonna help you with the project, because we talk about stress testing in the project. So stress testing is kind of like you give them you like gave out a scenario, and under this kind of scenario, the scenario is always a stress the scenario. So under this stress, what's the return your portfolio gonna be like? So my stressed scenario is like the croissant like gonna be 10% down, and Apple gonna 5%, and G is 20% down. So under this stress scenario, so what is gonna happen to the market? So first you have to create this new data, the new scenario. So if we check it out, it's gonna be like this: the croissant, the Apple, the GE, and then we're gonna use the command predict. The first argument is your what you're gonna predict and the data, and then this is the interval equals predict. This means the predictor. This means the interval type as predict, and we use the default of 95% confidence level. So here will tell you the predicted number of the dependent variable and its lower bound and the upper bound of the within the confidence interval. Here is 95%. So let's run this code. It's gonna give you the what is the estimation, what is the prediction of the dependent variables given this scenario, and it's gonna be minus 0.10848 something, and then the lower range and the upper range gonna be like this. So the prediction itself already calculates the confidence interval for you. And actually we can let's say this formula. This is I write down the formula here. So look, it's quite similar here. Okay, it's almost the same. But another thing you have to keep in mind that sometimes we see that some independent variables, the coefficient of them is insignificant. That means the coefficient should be 0 here. So it's not significant, then it should be 0. But when you are calculating the prediction, you should still use the coefficient that the R tells you and the regression gives to you. You cannot just write a 0 here, although in this regression it should be 0, but you can write 0 here. Look like this, the intercept is insignificant, so the intercept should be 0. But if you just write this down and assume that the intercept gonna be 0, then after calculation it's gonna be kind of like far away from the real prediction, from the real number. So even though it's insignificant, you cannot use 0 here to predict. Okay, I think that's all for today's video. We talked about the multiple regression, and I hope this is gonna be helpful to your project. Thank you.